So let's start with number 1. And these first few problems I'm going to go through pretty quickly because there's not a whole lot of new stuff for me to talk about. It's just a matter of just practicing at this point and becoming comfortable with these steps. So we're going to add 2 to both sides. And that gives me 3x is less than 12. Then divide both sides by 3. And I get x is less than 4. So I'm going to plot a 0 and a 4. Draw an open circle pointing to the left. So that's a problem that could have been on your quiz today, right? Like there's nothing too interesting about that one. And so the rest of these on this page are going to be kind of like that, where they're pretty easy. So let's look at number 2. Same deal here. We subtract 8. We get 4a is greater than or equal to negative 8. Divide both sides by 4. So we get a is greater than or equal to negative 2. So on the graph, just make sure you have 0. And make sure you have this number in question, negative 2. Is this going to be an open circle or a closed circle?
Closed.
Closed, good. And the arrow should point to the right. Now I noticed on some of the quizzes, I'm not going to take off points at the moment, but some of you are just sort of like drawing a line with no arrow. So make sure you're putting that arrow to make it very clear that this graph is continuing past this little grid. Okay? So in other words, like if you're doing something like this, you know, moving forward, that's not going to be good enough, especially with what we're going to do next time. So make sure you do include that arrow at the end. Any questions about 1 or 2? Yeah, let's move on to number 3. So in number 3, what do we need to do first here? So we do want to multiply both sides by negative 3, but not yet. Yeah, we've got to take care of the addition subtraction first. So we're going to subtract 2 from either side, which gives me b over negative 3 is less than or equal to 1. And now we'll do the multiplication. So times negative 3 on either side. Gives me b. Now I multiplied by a negative. So yeah, I've got to flip that sign. Okay? So less than or equal to becomes greater than or equal to negative 3. I'm going to continue to highlight anytime we multiply or divide by negative, because I think of all the steps, that's the easiest thing to miss. That's usually, like, if you're going to miss something, that's the most common error. All right, so that's going to be my solution set. B could be anything greater than or equal to negative 3. Another way to say that is that B is at least negative 3. 0, 1, 2, negative 3. Got a closed circle pointing to the right. Now number 4 is the first time we've got a distributive property in the context of these inequalities. I don't think we've had one like that yet, but it doesn't operate any differently than when we were doing equations, so no surprises here. Just make sure you take care of that distributive property first. Okay, you always want to simplify the left and right hand side as much as possible before you start moving things around, before you like add something to both sides or multiply something to both sides. Make sure that each side is simplified up front. So this will be 8 is less than or equal to negative 4d minus 4. Make sure when you do distribute, especially if this number is negative, that you are multiplying by a negative. So I'm going to add 4 to both sides. Get 12 is less than or equal to negative 4d. Then I'm going to divide by -4, which, because I'm dividing by a negative, that's right, got to flip the sign. All right, so that gives me, let's see here, -3 is greater than or equal to d. Yeah, so I want the variable on the left-hand side. So I'm just gonna sort of just reverse the whole thing. I'm gonna write an equivalent statement. I'm not gonna change what it's saying. I'm just gonna rewrite how I'm saying it. Yes, ma'am.
Oh, never mind. Just kidding. Wait.
Well, what were you gonna say?
I'm just confused because isn't it supposed to be 4d plus 4, and then you're supposed to subtract. I got -1.
Yeah. So I see what you did, but let me back it up a little bit. What's -4 times 1? -4.
Oh.
Yeah. So, and that's why I really want to emphasize, when you're distributing, if that number that you're distributing is negative, you've got to carry that negative with everything that you're multiplying it to. So just, yeah, be careful about that. So yeah, I'm just going to rewrite this as d less than or equal to -3, so that this little arrow can indicate which direction the arrow is going to go. So 0, -3, close circle, going to the left. All right, so just a few more before we start getting to the special solutions. Now, in this case, I've got variables on both sides. Don't let that throw you off. Just know that you need to get the variables all to the same side. So I'm going to start this one off by adding 4n to both sides. So there's sort of two schools of thought here in terms of like which direction should you take all your variables. Like I like to get all the variables to the left-hand side. But now in this case, it probably makes sense to do this either way. But sometimes, like if I do that, that makes the left-hand side negative. But to me, it's almost worth it so that you don't have to flip it at the very end anyway. So I would recommend that if you have to combine terms, like if you've got variables on both sides, is take all the variables to the left side, and that way you don't have to worry about flipping it at the end. So we've got 5 plus 2n is greater than 8. I'll zoom in on here. See a little better. Then I'm going to subtract 5 on either side. (2n) is greater than 3. That looks like we're going to end up with a fraction here. Divide by 2. So what's 3 divided by 2? You can leave it as a fraction, 3/2. That's perfectly fine. So you can just leave it like that. Or if you prefer the decimal, that's okay as well. If you want to write 1.5, if that feels better on the inside, then you're more than welcome to write it like that. So we've got 0, we've got 3/2. Now that's positive, so it goes on the right side of 0. Got an open circle pointing to the right. See if I can fit all that on. There we go. All right, let's do one more. All right, so for number 6, we've got to get the variables all to one side. So if I'm trying to get them all to the left side, what do I need to add to both sides?
4p?
Yeah, 4p. So I'm going to say plus 4p plus 4p. So that gives me 7p plus 4 is greater than or equal to 25. So I'm going to subtract 4. Which which leaves me with 7p is greater than or equal to 21. Divide both sides by 7. So p is greater than or equal to 3. Got a 0, 1, 2, 3, closed circle going to the right. So there's nothing really that much different than what we've been doing here. So there are two special solutions, okay? One special solution was the fact that it's possible to get no solution. So when all the so actually I'm going to write it up here. So no solution when the statement is false. Right? So like if all the variables cancel out and you get a false statement, like when we're doing equations, you would get something like 1 equals 2. But here you would get something like 1 is bigger than 2. Right? So it's the same kind of idea. You just get a false statement. You would say there's no solution. Now, if you get a true statement, instead of saying infinitely many solutions, because that's not really going to be descriptive enough here, we're going to say all real numbers. Okay? So we're just going to tweak the verbiage here and say all real numbers when the statement is true. So what I mean by the statement being true is like if all your variables cancel out and you get something like 3 is bigger than 1. Well, that will be true no matter what, right? Like 3 is always bigger than 1. As long as the units are the same, I guess. So when do these solutions occur? When all the variables cancel out. In other words, like if you've got, let's say you've got like 5x on both sides and you do minus 5x and then all your x's sort of go away, then you'll just be left with numbers on either side, you know, and it'll be something like 5 is greater than 2 or 1 is greater than 0 or something like that. And then you determine whether or not that statement is actually true or false. Any questions so far? So we'll look at a couple where this happens, so you can kind of see it in action. All right, so we'll work these out pretty quickly because what we're going to see, really, I mean, very quickly, whether or not these are going to be true or false. So like number 7, right away, I'm going to subtract 6h from both sides. And so I'm left with negative 18. Notice the h's cancel out on either side. Negative 18 is less than 1. So all my variables are gone, so it's not like I'm finding a solution set anymore. I'm now just trying to figure out, is this true or false? So what's the case here? So this would be, is negative 18 less than 1? Yeah, that's true. So I'm just going to make a little note that that's true. So the sort of solution set, or what you're going to state as your quote-unquote answer, is all real numbers. And basically what that means is every single number on the number line is a solution. So any number you pick to plug into h here will work. So as far as like how do we graph that? Well, if we want to, you know, typically these graphs are trying to visually show where the solutions are. So if every single number is a solution, then we need to show that by just, you know, drawing an arrow in both directions. So there's nothing left off. We're just saying that everything works. Any questions about that? What do you guys think we're going to write, or how do you think we will graph something that has no solution?
Just don't graph it.
Just don't graph anything. Yeah, pretty much. Okay, so for number 8, I'm not sure which one this is going to turn out to be. Let's just see real quick. We got 3j plus 6 is less than negative 2 plus 3j. I kind of like these special solution ones because typically you're able to solve them real quick. It's like once the variables cancel out, you're more or less done. So yeah, we're gonna subtract 3j from either side. And we get a statement 6 is less than -2. So what do you think? Yeah, that is definitely false. So our answer is that essentially there is no answer, right? There is no solution. There is no number on the number line that will work. So as far as our number line graph, if we want to indicate that nothing on there works, we just don't plot anything. Just leave it blank. So I'm going to write, for now, you don't have to write, I mean, maybe you want to write this just because these are your notes. You know, on a regular basis, you don't have to put anything there. I'm just making a little note, leave blank. But when you're working it out, don't write leave blank as your answer, you know what I mean? Like, this is just for your information. You look back at this and you think, okay, well, how do I do that? You leave it blank. Yeah. So on all the rest of them where we get no solution, I'm just going to actually leave it blank instead of saying leave blank. So these last few are just, you know, kind of putting everything together. These are about as complicated as the inequalities we're going to have to solve are. So let's just kind of run through these that have distributive property, variables on both sides, undoing. I mean, they've got everything. So smorgasbord of steps. So we'll start by distributing. All right, 12 times 1/4. If you're not sure, use a calculator, but yeah, it's 3w plus 12 times 3 is 36 is less than or equal to 3w minus 12. So we're going to subtract 36. Oh, no, not 36. What am I doing here? What should I do? Wow. Yeah, I went off into the deep end there. I don't know what I'm doing. Minus 3w is what we want to do there. And so we get 36 is less than or equal to -12. True or false? False, definitely. So we're going to say no solution. Now, the one thing I will ask you to do as far as the number line is concerned, just to show me that you just, you know, I want you to be able to show that there's no solution, but, you know, so I don't want you to draw a line or anything, but throw the 0 on there just so you're acknowledging that you're looking at the graph. You know, put something on, you know, label it somehow. So if you just totally leave it blank, I might wonder, oh, did they just forget about that, or do they actually know? But if you like put 0 or whatever, but 0 is probably the easiest thing to remember because you're doing that anyway for all of them. You know, just put the 0 on there to acknowledge, hey, I'm looking at this and I'm saying there's nothing there. So I'm just leaving it blank. Number 10. It's got a bunch of steps as well. We're going to combine these like terms. We get 3g minus 4 is less than or equal to -3 plus 3g. So again, once you like kind of see that you've got the same number of variables on both sides, you know you're going to have one of those special solution cases. Minus 3g on both sides gives me -4 is less than or equal to -3. Now just be -3. You know, negatives can be a little tricky. For sure, but is this true or false?
True.
Yeah, true. So I say all real numbers, meaning x could be any real number. So I'm going to do an arrow in both directions. Okay, let's look at number 11. We're going to subtract n on both sides. Oh, we're not going to get a special solution here. How great. I was kind of getting tired of those. So we got 7 minus 4n is less than or equal to 3. So minus 7 on either side. Gives me -4n is less than or equal to -4. Oh, yeah, so the 7 itself is
Yeah, it's already
positive.
positive.
Right, yeah. So then I divide by -4. And I get n is less than or equal to, oh wait, nope.
It's great. You have to flip it.
Gotta flip it. Good catch. See, even I miss it sometimes. You gotta be vigilant about it. 1. So 0, 1, close circle, going to the right. Yeah. All right, let's do one more, and then a couple of word problems, and then you can spend the rest of the time working on your homework. Although some of you probably already started, yeah. Hopefully. All right, number 12. Distribute the 2. So we get -8s plus 4 is greater than or equal to -6s minus 10. We're going to add 6s to both sides. Now you could add 8s to both sides, but then you're going to end up with the variable on the right-hand side, and it's going to give you an extra step. So let's just leave it on the left. So that's going to be -2s plus 4 is greater than or equal to -10. And we just go through our normal steps. No surprises after that. Just make sure that when you get to the point where you need to divide by 2, or divide by -2, don't forget to flip that sign. Okay? It's going to be the easiest thing to forget, because that's the only thing that's different than just solving a normal equation. So yeah, I might run out of room here. Let's see. Divide by -2. Try to squeeze it in here. S is less than or equal to 7. All right, so we put 0, throw a 7 somewhere over there, close circle to the left. Any questions? All right, so let's put it all together. Let's take a look at the bag. Last page, 2 problems. The area of a rectangle is greater than 60 square feet. So in order to answer this, you need to know, so this is going to be sort of assumed knowledge here. How do you calculate the area of a rectangle? Length times width, right? Or base times height, however you want to think about it. Basically, you multiply the 2 dimensions together. So if I want to find the area of this, it'll be 12 times 2x minus 3. And it says the area is greater than 60 square feet, so greater than 60. And we're looking for possible values of x. So I'll start by distributing the 12. 24x minus 36 is greater than 60. I'm going to add 36. So we get 24x is greater than 96. Ooh, this division is not going to be pretty. Let's, if you're not sure, use a calculator. 96 divided by 24.
4.
Oh, it works out nicely. Oh, look at that. X is greater than 4. I mean, x could be any number bigger than 4, and it will satisfy the conditions laid out in the problem.